Quick look view. Here we are going to examine the various codes that were used in each of these stuff. We are starting with the welcome page. These are the key performance indicators. Okay, in order to get the reload time actualized, we have this last update is equal to last update. Last update is a text, and there's a concatenation reload time. That's a function that is known. Good. So that's the only parameter that requires a formula or a function in this welcome page. Now at the level of main, let's first of all have a quick look on our edit script to see how the functions are displayed in the edit script. I'll just scroll, go back right up. Good. So all these ones are standards. They are global variables that are set, and this one, let this my local variable, let be my time equals reload time. This is my local variable, and from directory I have what we call the tables of my Excel sheet that I imported into quick look view. Now interval, date, timestamp, all this stuff are my functions are integrated into the script. Alright, to calculate day div, add div, eds, so it can be seen here. Okay, so we'll take this first two. You can see how it goes. Okay, they are all in timestamp. They I wanted to get the difference in time between the date of closing the ticket and the date of creation in this and in hours. Here I want to get the difference in time between the date, the final reparation date, and the date of creation of a ticket. I believe it's still in days and time. EDS days div, EDS hour div. Okay, and finally here I wanted to get the date of creation of ticket and the date of the first is the date of creation of ticket. There are different intervals between the date of creation of ticket and the date where the incident actually occurred. That's that dB ticket, and also the date of closure of the ticket and the date where the last reparation was made. All these ones were calculated in minutes. That's how min div 1 and min div 2. Now coming downwards, I have as date creation the ticket. It means I get the date of creation of tickets in hours. I get the date of creation of tickets in months. I mean the month of creation of a different ticket, the year of creation of a different ticket, week and day. Okay, so with the function R of this particular column, it treats only the hours where the tickets were created, maybe from midnight right up to 12 hours of the day, 24 hours of the day. Okay, so that's all about my script. Now we are at the level of main. These are all lists. These are lists. The ones by my left, they are lists. Now this is where I use the function. I probably calculated something. Let's get ticket created based on priority. All these things are in the block note that is attached to this file. Okay, so I need to get the priority against count in ticket, distinct count in ticket. So that's just the expression, the simple expression that gives all that. Likewise, this I have to get the state and the total number of tickets created. I believe is still distinct. Yet type of ticket and the total number of ticket created is distinct still, and likewise the criticity. Now coming here, this is simply my year of creation, what I have in my script. Month of creation, it gives the various months that we used in creating the ticket. So discover that for this file that I have, the last ticket was created on October 2nd, right? So that's the importance. Then I have week of creation. So I've created many tickets. So if I click something like September, I can see all the weeks that we created tickets in September. Day of creation, if I choose, for example, September, see that we created tickets in 5 weeks. If I choose week 39, you can see the days that we created the ticket: 19, 20, 21, 22, 23, 24, 25, and we created 121 tickets. Good. So I'll clear these selections. Okay, now very important, extraction date. This one is a calendar, and let's see what it has as formula. For this calendar, I have first of all a slider or calendar object. So I can either choose a slider or a calendar. I highlighted variables, and I got my variable. My variable is v my time. It is what is as a local variable in under my script, and I set this minimum value. The minimum value is equal to min 1 date creation of ticket. Normally when we put 1 in set analysis is to like annulate all previous selections in that particular function. 1 is like a reference, like no selection has been made, no preference has been made. That's why we usually use 1 in our functions. Okay, max, I see we maintain 1. It means it's like you're initializing before you give an action. I initialize the set analysis before saying that okay, I need the max of date of creation of tickets. Good. So that's just all what I do here under the calendar. So it means that the calendar takes into consideration the date of creation of all the tickets, and it displaces them here. You see that this file was exported on the second. The last ticket was created on the 2nd, so the maximum date here is 2nd of October 20, at this particular time. So I cannot choose any date that is greater than that time, that specified date, because my calendar specifies that the minimum and the maximum only. Now let's check our input box. What does our input box say? Our input box takes into consideration my time as variable. Now we should know that this input box, that my time by default is the reload time. Means when you reload your file, it takes that particular time as the constant time. So we go now to constraints. At the level of value, we have this time here. Once I change on my calendar, it means I'm giving my my time, that's the local variable, another time which is the maximum date of creation of the ticket. So this is what we have here. Automatically changes it in the input box too. Okay, but now how does the input box work on its own? The input box works on its own. First I need to put a variable, and the variable is my time. Next, constraint, I need to setting for selected variable value, give it a value. How should it look like? It should look like this. The number, timestamp, means I need the date to be in this format. Font, not very important. Layout, caption. Good. So you discover that at this level, if I change this date, since my time remains a variable, once changes have been made, it changes everywhere. Okay, I've changed the date at the level of the input box to 1st October. Automatically changes at the level of my calendar. If I change at the level of my calendar, it will change at the level of my input box, because I'm using the same variable, my time. Now let's go to KPI 1. I believe all these ones are, all these expressions are in the block note, so I'm not going to waste time on there. All these ones are trivia that are in the block note. The third, okay, I believe these ones are also in the block note, but here there's something that is intriguing. I will start with this. Here I get the priority of the product. I get the count, the number of tickets that were created within the period, which was less than 2 hours, 4 hours for this, for priority P1. and number of tickets that were created when it was greater than 4 hours. Now the delay the number of tickets that were closed, these are closed tickets. The number of tickets that were closed with the time less than 4 hours was 36. The number of tickets that were closed at the time greater than 4 hours is 81, and the percentage delay in closing ticket was 69.2%. Now here instance, this is the percentage delay according to the operator, that is according to the activated EDS, be Huawei, be Ericsson. So here what do I have as formula? First, my x-axis is clear, it's just my priority. But now the level of the other tables, I have count less than or equals to MTTR. What did I use as expression there? Okay, I said distinct, count distinct as diff, that's the interval between the creation of ticket and the closure of ticket. I say as diff, this set analysis is equal to curly brackets less than or equals to 4, where the priority of treatment is P1 of number of tickets. It means I have reduced that search to only tickets that were closed within the time base equals to 4 hours, and their priority is P1. Now for this is clear, it's going to be tickets with RDIV greater than 4 and their priorities P1. And lastly, with this I want to get the percentage. So of tickets that were closed after 4 hours on the ticket that were totally closed times 100. That's the percentage of closing a ticket late, not the percentage of closing a ticket early. I get count distinct RDIF greater than 4 for priority P1, all divided by all the tickets that were closed under priority P1 times 100 over times 100. So I have that. Now this count is supposed to be for the ADS, count ADS, right? ADS delay, if I can put it that way. It means this is what the activated ADS says is used as time, as delay, is percentage delay. Now I get count distinct ADS RDIF. This is ADS RDIF is the difference in time between the last date of reparation and the date of creation of a ticket. It's the difference in interval in hours between the date of reparation and the date of creation of ticket. Here the ADS does not care if the operator or the monitorer uses more time after the ticket has been closed, after the ticket the site has been repaired. If he uses more time in closing the ticket, it does not concern the ADS that is concerned, that is being activated. The ADS is in charge, is saying that I use this number of time to finally repair the site. So if the operator refuses to close the ticket, it's his business. So yeah, I took the interval of time between the date of the last reparation and the date of creation of the ticket. So when it's greater than 4 and the priority is P1, divided by all the tickets that had their last date of reparation where their priorities are P1. Okay, as you can see, good. So that's what I had there. Okay, so you can see it. So that's just all. So for the rest, it's almost the same thing, it's the same formula. So now we'll go to KPI 3C. With KPI 3C, here I need to get all the tickets that are still in course but they have already surpassed their threshold. They are in course but they have surpassed their threshold. What do I mean here? It means that you were supposed to be closed for 4 hours, but you have already used more than 20 hours and you are not yet repaired. You are not still repaired, means you are still in course, means there's a problem. So here I have these are tickets for priority P1. Let's see how the calculations were made. I believe nothing complicated was done here. For take 2 in hours, here I got the formula here was, okay, let me just open take 2 or take 1 expression. Okay, only eta equals to anku. Eta is a table in my it's a table that was imported into QLIKVIEW. So when it is anku, it is in course, right? When the state is in course and the priority is P1, then you do this variable date. Now this was variable date. Variable date entails something else, which I would not like to go there. I'll just check a tab too if I thought I use variable. I concatenated everything with a variable. It has been long since I did this. So I have to go and investigate what variable to. Okay, what variable true is all about. Only eta and cool priority statement. Okay, so we need to investigate what variable 2 is all about, and variable 1 too. So we'll go to layout, no, selections, no, view, somewhere here to get variables. Okay, just come here. So the crux of the matter here is to get the variable. Okay, so we'll go to setting, variable overview. Our main variable there was date 2 that I wanted to investigate. Date 2 is actually the interval of time between my time, what to set as the extraction date, is the interval of time between the extraction date and the date of creation of ticket. Interval of time between the extraction date and the date of creation of ticket. That's just all. So since v my time is a variable, that's how I represent it. But if you see date creation of ticket is a colon, that's why it is being represented and highlighted like this. Okay, so it means that at the level of this English Ketemanganku, I had here, I will take only the tickets that are in course and their priorities is P1, where this is date, not even date 2. Okay, what will I have for date? Where the date there is I will just go back. Where the date there is interval, date times time, my interval of time between my time and date creation of and date of creation of a ticket, right? So this one is in day. Okay, date 2 is in day, while date 1 is in hours. So it means you get only eta and cool for priority P1, where we have this difference in this. Then for take in hours, I believe we just had a condensed v variable 1. What is v variable 1? You can see here eta and cool priority is P1, where I get this is the interval of time, means this variable englobes 2. Okay, so that's it. which was condensed to be my take in hours. And written as those. Simple. So that's what applies here. And this date of extraction in fact is it v my time and date of extraction. This one changes. It means by default it is normally the reload time. By the time changes, it also changes. Once I change from the calendar, I can also change here. Okay, we'll go to KP4. KP4, this one is in the block note. It's pretty easy. Yeah, I need the hour of the day and the number of tickets that were created. So I say count ticket where hour is from midnight to 6 and from 7 p.m. to 11 p.m. So these are represented. Where CR was a table that was inserted in the level at the level of the script. That's what gives this. Likewise for a wrap, then I can also get the charts. The charts are all in. Okay, the charts, ticket count, where am I counting my tickets, non-overlap. That's it. Good. And I used a cyclic group. KPI 5. Yeah, I need to get the delay in creation of tickets. So what did I do? Here I have the priority ticket closed within the period less than 60 minutes, ticket closed after, ticket created less than 60 minutes from the time of incident, and ticket created greater than 60 minutes from the time of incident. So how did I get that? Ticket created less than 60 minutes from the time of incident. I had to get the mean diff1 equal to set analysis less than equal to 60 of the creation of ticket. What is mean diff1? Mean diff1 is the interval of time in timestamp between the date of creation of ticket and the debut the incident and the date where the incident actually started. So that's my mean diff1. Okay, and yeah, I just needed to get mean diff1 greater than 60 minutes of date of creation of ticket. I'm doing this thing count here. Good. Then I have the chart that represents it. Delay ticket creation. So here I wanted to treat only those tickets that were created that were created 60 minutes after date of creation, after the debut, after the start of incident. Now my cyclic group. Yep, which is made up of criticity and état, priority, type de produit and type de ticket. Good. So this section is just the mirror image of this one. Here I have delay in closing of ticket. What do I have here? I probably have okay, mean diff2, which is the interval of time between the dernière date de réparation and the date de clôture de ticket. So when mean diff2 is less than 60 minutes, we have the number of tickets that were closed at that time, and when it's greater than 60 minutes, we have the number of tickets. The reason why this one is high has been explained in the previous videos, that many operators claim that they repair their ticket earlier, why it is the operator that uses more time to close, whereas the operator watches from his monitor that the site is actually up. he has to watch that the site is actually up before he closes the ticket. So it means an operator can claim that he has repaired the site by at 10 a.m. whereas the monitorer actually make sure sees that the site is up by 12. So he will be closing the ticket by 5 past 12. With respect to the operator, with respect to the ADS that was activated, he is 2 hours 5 minutes late, whereas with respect to him, he has just used 5 minutes to close the ticket. So that's where we have this number always inflating. That gives us a percentage delay of 41%, while for creating the ticket is usually very low. Okay, personnel, this one is, there's no big deal here. We just need the personnel and the total number of tickets the personnel created, distinct, as well as here. Okay, and now for the last one, here we had state 1, state 2, and the rest. Okay, we're going to explain that. Here we have state 1 personnel, state 2 means I want to compare two people directly. So you create a state in a list box. You come here, by default it is always at inherited. Alright, if I want to create a new state, you just click on new and you create. So I'm at state 1. Okay, I'm at state 1, and I also create another one for state 2. That's the only thing I do with this, with the list box. So I come now here where I want to display them. I'm displaying number of tickets created. I want to display, okay, I have my cyclic group in my x-axis, and my y-axis state 1 personnel. What do I do with it? I say count distinct. I need to count distinct number of tickets, right, for that particular personnel, but I will click on count distinct. Here I put in curly bracket, my set analysis is state 1 hash a $sign. That's the syntax. State 1 hash a $sign means it takes into consideration only the names of state 1 that has been highlighted. State 2 is same, count distinct state 2 hash $sign takes into consideration only those of state 2. Okay, that's it. So if I click on, I'm now comparing two people, Mr. Ade Monkey Kelvin and Songi Francis. Those are the two people I'm comparing. Let me make sure I am in OCM SMC monitoring. Okay, so with this, it does not, because of the states that I have, it does not sort this table based on only those who created tickets in OCMC monitoring. It takes all the names in the particular table, means you can compare anybody with anybody. Okay, so that's how it works. So this stuff here, this table was just gotten from this graph. Okay, so that's how I can explain the work that was done in Orange, Cameroon during the start of pre-engineer. Ciao.